Joe Dumit, and I teach anthropology and science and technology studies at the University of California, Davis. My first appointment is professor of science and technology studies, and I'm also a professor of anthropology, and I'm currently also chair of performance studies. STS is it's a collection of different approaches to how science and medicine change. So it includes, for me, history, philosophy, social studies, sociology, anthropology, and increasingly other disciplines, including performance studies, cultural studies, all looking at ways in which science and technology are in the world and the way in which the world is in science and technology. My STS4 research started at Rice University as an undergraduate. Sharon Trawick was one of the core figures in the creation of STS as an anthropologist who studied high energy physics. And she also brought an ethical, class, gender analysis to looking at how science and technology change. And she introduced me to the History of Consciousness program, where I went on to do my PhD in working with Donna Haraway and feminist STS. It's kind of my core formation, was especially the early debates between Donna Haraway and Bruno Latour over an actor network theory approach to STS versus let's say a more historical, political, economic approach to how things changed in the world. My initial research was on PET scan brain imaging, and there I was interested in how a new technology that could look inside the brain as it changes, what did scientists think was an important question to ask with that technology? Why in the US was gender and different forms of class, and especially sexuality, these were things that they thought they could find in the brain. And I was curious, culturally, socially, why those became important questions, and then what they were able to do with brain imaging to try to answer those questions. And the weird answer was they really couldn't answer those questions, but it didn't matter, because the fact that they had studied those questions with brain imaging tools meant that those answers traveled popularly, they traveled to courtrooms, that scientific facts had effects in the world, whether or not they were robust scientific facts. And that then led me to actually looking at social movements, political social movements around environmental toxins, multiple chemical sensitivity, attention deficit disorder, Gulf War syndrome, which then became post-traumatic stress disorder, looking at how patient movements used the internet to organize. And to create collective archives using this new technology at the time to create, let's say, collective resources to respond to institutions that were attempting to deny them services. And so I was fascinated with the way in which hospital systems were trying to deny as many patients as possible in a lot of circumstances access to services. And the patient groups were able to respond collectively to that. And one of the ways in which they responded was actually using brain imaging as a weak technology, but because it was weak, they were able to generate facts that could also travel into the same systems. So the thing that I thought was a bad thing also turned out to have lots of good consequences too. So it left me with seeing many sides to something like neuroscience. But in doing that study, I was led to study pharmaceutical companies, because it also turned out that pharmaceutical companies could use the same techniques of amplifying facts to increase sales, regardless of the underlying need for those sales. Probably the nicest way to say that. So studying how capitalism could affect the effect of facts in the world, how it could amplify certain facts over other facts, how it could make certain questions not important. and make other questions important. That became the kind of topic of my second book, Studying Drugs for Life. Maybe like another interdisciplinary project I've been doing, which is working with the Keck Caves at UC Davis. And this is a like long-term collaboration between, well, this isn't going to get outside of academia, but but it is an example of interdisciplinary collaboration and the way in which STS has been very useful to helping make an interdisciplinary project better. So this was a 3D virtual visualization technology. You put on a headset, 3D glasses, and you actually see data float in front of you that you can manipulate. And it took 7 years of geologists and computer scientists trying to talk to each other to actually create a collaborative tool. And this was partly because they didn't realize how much they didn't understand what they were saying to each other. And it took these years of meeting every week to be able to come up with questions that they could actually share graduate students around. And I was brought in partly as someone who studied how interdisciplinary groups collaborate, because PET scan research was a collaboration of 6 or 7 disciplines, and pharmaceutical clinical trials also brought together many different disciplines to create one object. And so I was able to work with them and help them think about how to get interdisciplinary grants from the NSF, and maybe even change how the National Science Foundation in the US reviewed interdisciplinary grants, which meant understanding how each discipline functioned separately and why different techniques of reviewing grants weren't always successful. Like if you needed something to be cutting edge in computer science and in geology, you often couldn't get a single project through, because each group had a very different idea of what was cutting edge. And so you might want something that in computer science was applied. But computer science researchers wouldn't consider that to be cutting edge, even if it had never been done before. So some of what I did was actually work with them to think about how granting agencies worked, which is something that STS often does, which is look at how infrastructures of knowledge production help shape how knowledge is produced at the disciplinary level. You often see national differences, governmental differences, agency differences, and disciplinary differences. The topics I've studied have changed over time. And like initially I was very interested in visualization as like the power of visual images in the world. And my whole first book was going to be about the power of images. And then I realized as I was studying it how much important the political economy was. Like who's in charge of funding agencies are in charge of funding certain types of questions over other types of questions. And so the kind of larger, let's say, capital and political interests were shaping which questions got asked in the first place. And then again in my pharmaceutical research, again I thought advertisements, because in the US it's you're able to advertise blanked on the word. In the US you're able to advertise prescription medicine directly to consumers with TV commercials, which in most every other country in the world seems absolutely absurd, to sell a cancer drug or a diabetic drug online rather than actually having your doctor prescribe to you the most appropriate one. And I thought that that would make a big difference. But then as I actually interviewed and talked with pharmaceutical marketers, it turned out, no, that didn't really sell anything. It made a little bit of profit, enough to make the commercials worth it, but all the growth in pharmaceutical companies came from the actual design of clinical trials, designing clinical trials that could actually sell more drugs, which struck me as quite unethical, but was allowed. This putting the question of designing a clinical trial to sell more drugs rather than to save more people is the kind of horrible calculus that emerged from that type of research. So my interest became more and more interested in political economy, in how Marx saw capital, being formed and looking at the way in which political economy shaped cultural questions. One of the big strands has been, and this is the one that I participated in, is actually looking at the power of corporations to shape what counts as science and what counts as technology. And in a sense, we'd always known that militaries and companies had played a big role, but a lot of early STS, for a number of reasons, partly coming out of the history and philosophy of science, focused on laboratory science, academic science, and so didn't always pay full attention to corporate science and kind of military science. And then military science was starting to be studied. I don't have a good timeline for this. But then seeing, I don't know, you could say 80s and 90s, as companies started becoming, consolidating more and more into giant multinationals, the scale with which they could approach both scientific research and the public relations, the propagation of what facts matter, they reached a scale that was kind of unbelievable. Like when a pharmaceutical company has 300,000 employees, they can spend 90% of their employees looking at how to do research and worrying about their competition. That still leaves 30,000 people to try to manipulate the environment, meaning to change the landscape of facts in the world through what they publish, to spend money on ghostwriting in journals, to lobby governments to change what counts as proper medicine, all of which are in a sense legal, right? These are like, I'm not talking about absolute corruption, I'm talking about kind of legalized corruption. Where a company's vested interest is to increase their size, to increase their share value. And they're willing to do anything possible to do that. And that often means intervening in everyday science, in good science. It means changing what counts as legitimacy to the extent that they can. And a lot of the work that's being done now involves looking at you could say, the effects of that practice over the last 40 years. So chemical spills and how they affect people, the way in which corporate tactics around where they locate companies, and what knowledge people get access to shapes, people who live in poorer neighborhoods then get differentially affected by these things. And so this is, forced, brought into awareness in STS. Working with the traditions of academic and community knowledge, that have worked with affected communities for a long time. There's a kind of meeting point where they also want STS to help them understand the knowledge creation process and the knowledge production and dissemination process. So how communities are affected meets also how we know about the world. And for a long time, I think academic communities separated those two research agendas, and bringing them together to look at how the way in which facts about the world are produced is playing a similar role to the way in which how inequality is being produced, and different life chances are being produced in the world. And I think for me, that's one of the most exciting parts about the future of STS, is stuff that looks a lot like activism, and in some cases is direct activism, but is also the natural kind of outgrowth of how, sorry, I'm very distracted by the light. It's the natural outgrowth of how knowledge is making effects in the world. And it's not just about the production of facts, but it's what those facts do in the world. And that, from a corporate point of view, is never separate. They never think about producing research without also thinking about what they're going to be able to do in the world with that research. And I think we're, as a community, a little bit late to actually study, to realize how much that's part of the same process. And that we can't talk about knowledge production without thinking about how that knowledge is being used in the world. Giving undergraduates training in STS is a way of helping them who already have a desire to understand an interconnected world, a complex world, giving them the tools to understand that. And one of the things I think about STS is doing is saying, what's the problem you're trying to actually understand, and which disciplines, which methods are appropriate to understanding that? To actually let them run out and try to formulate what the problem is, and then have them come back and say, I think I need to understand the history of this, or I think I need to understand why the government isn't doing anything. And then we can ask, okay, well, what are the tools for understanding why there isn't government intervention here, and what's really the problem we're trying to solve? So I think for me, STS is teaching people how to use the full interdisciplinary array of tools to actually look at a problem. And what's really nice about STS, and something that has changed over the last 30 years that I've been doing this, is science and technology are now everywhere. Like, there's no way to think about something in the world without already knowing that it's got scientific and technical issues. Like what used to be called high technology, like the internet, things like that are now everyday occurrences. And similarly, medicine has become high tech, meaning that every question you have about health also involves questions about the research, the science and technology behind it. So students from lots of different, like students going anywhere into the job field, this is always a tool that helps them be better at what they're doing. And at Davis, I've been creating a data studies program, kind of undergraduate minor and maybe a major, to understand how data works in the world. And we did this partly by going to companies and asking them, what do they want? Like companies that hire data scientists, why would they also want critical thinkers? What was surprising is across the board, companies wanted critical thinkers, people who could think historically, sociologically, ethnographically about the problem that they're facing, and that was the same thing as the data question that they were trying to answer. Because they always had this problem that if they came up with a question first, they could get an answer with data, but they couldn't actually know if it was the right question. So having people who have that reflexive quality, who can step back and say, well, what's causing us to ask this question? That's the kind of thing that lots of disciplines do, and STS focuses specifically on how can we look at the scientific and technical resources that are available to answer that question.